So what we have here is what is called a complex fraction. A complex fraction has more than one fraction bars. We have 1, 2, 3, 4, 5 of them. So that's too much. And so we have to simplify this fraction until it just has one fraction bar. So there are two ways to approach this. I'm going to show you both. The first one is basically what we would do if these were numbers. Just think about it. If we had 1 over 2 minus 1 over 5 divided by 1 over 6 minus 1 over 25, something like that. So then we would bring the top on the common denominator and subtract, same with the denominator, and then we would divide by multiplying by the reciprocal. So we're just gonna do the same thing, but this time we have letters as well. We have variables as well. Okay, so in the numerator, the least common multiple is 5x, and x to 5x, we multiplied x by 5, so we have to multiply 1 by 5. And indeed, 5 over 5x will simplify to 1 over x. Minus, well, 5 to 5x, we multiplied by x. 1 times x is x. And then with the denominator, it's going to be similar, but instead of 5, it's 25. And instead of x, it's x squared. So from x squared to 25x squared, that was a multiplication of 25. 1 times 25 is 25, minus 25 to 25x squared. That was a multiplication by x squared. So if we had numbers, only numbers, this would collapse to a number, this would collapse to a number. We don't have that, but the principle is the same. To divide is to multiply by the reciprocal. So we're going to say 5 minus x over 5x times 25x squared over 25 minus x squared. And the way we multiply fractions is we multiply top by top, bottom by bottom. So we have 5x times 25 minus x squared and 5 minus x times 25x squared. So one fraction bar, this is what we needed, but we're still not done because this fraction is not simplified. We have common factors. A very easy factor is both upstairs and downstairs are divisible by 5, also by x. So let's get rid of that, but there is more. This might look a little strange, but if you do this, you don't have to write little numbers over the canceled out things. It's just 5x that's remained. Also, you can just go straight. You can skip over this step as long as you get it right. So we have 5 minus x in the numerator times 5x divided by 25 minus x squared. And the denominator can be further factored via the difference of squares theorem, right? Remember, a squared minus b squared can always be factored into a pair of conjugates as a plus b times a minus b. And that's exactly what we're going to do there. $25 is a squared, a is 5, and b is x. Then we have 5 squared minus, so if a is 5 and b is x, then this expression, which is exactly what we have, can be factored as 5 plus x times 5 minus x. And now we knock out what is common, and what's left can no longer be simplified. You might feel tempted to further simplify, like get rid of this 5 and that 5, but you can because this part is not divisible by 5. Same with x. Yeah, this part is divisible by x, but not this part. And we would have to divide both parts of a sum. So basically, this is the answer. Okay, so that's one method. And the reason I'm showing it to you, because it's intuitive, that's what we do with numbers. But there is kind of a shortcut to it, which is worth looking at it. Okay, so here is our expression that we want to simplify. And first, we want to get rid of the fact that it's a complex fraction. And so one fundamental property of fractions is that we can always multiply both numerator and denominator by the same non-zero number without changing the value of the fraction. So now what we're going to do is we're going to multiply upstairs and downstairs of this big complex fraction by something that blasts the denominators. So it has to be the same thing. And the denominator will need more. The denominator will need 25x squared. And so the numerator would only need 5x, but we have to use the same thing. So we're going to multiply upstairs and downstairs by 25x squared. Now, when we distribute, we get 25x squared divided by x. And that's just 25x. And then we have 1 over 5 times 25x squared. Just think about it the other way around. We're multiplying this thing by 1 over 5. So we just cancel out 1, 5. And that is extra here, right? Both pieces are divisible by 5. Both pieces are divisible by x because we use more than what we needed. Because this is the stuff that the denominator needs. Now, if we multiply 1 over x squared and 25x squared, or think about it, we multiply 1 over x squared by 25x squared, x squared is gone, and we're left with 25. And then here, similarly, we're left with x squared. So I just want to point out that this is really fast. Look at all these steps that we made, and we're almost here. We have to factor upstairs and downstairs, but it's just really an efficient shortcut. So we factor out whatever we can. 5x is what they both have. And then here we have 5 left. Here we have x left. 5x times 5, 5x times x. We're good. And here, via the difference of squares theorem, 5 plus x times 5 minus x. So we got there pretty fast. This is a very efficient technique, but it's not sort of what we do with numbers. What is interesting, and you could think about it, why don't we do this with numbers? Would it work if we use this blasting method with numbers? Think about it. Try a few examples. Thank you for watching.